Okay, this is SL Prep, and it's going to be Chapter 2.5, Writing Equations of Parallel and Perpendicular Lines. It's really nice when you're trying to find parallel and perpendicular lines to use point-slope form. It's not the only way you can find those lines, but it is a very quick and easy way to do that. The point-slope form, as you know from the previous recording, is y minus y sub 1 equals m, which is still slope, times, in parentheses, x minus x sub 1. Okay, so we're going to write an equation of a line that passes through negative 1, 4 and is parallel to y equals negative 2x plus 5. Okay, since we know that the lines are parallel, we're going to have the same slope. So the m on y equals negative 2x plus 5, the m is negative 2, which means that the slope of this second line, the parallel line, is going to be negative 2. So we're going to use the point slope form, so y minus y sub 1 is going to be this y right here, the 4. It's going to come down, equals, there's our formula, y minus y sub 1 equals m, we know is negative 2. So we know m is negative 2 from the other equation, times x minus x sub 1 is going to be the negative 1. So we're going to put in the negative 1. Now you have to be a bit careful. You can't leave it as minus and negative, so we're going to use the additive inverse. Y minus 4 equals negative 2 times x plus 1. Now that is written correctly in point slope form, but we have to simplify it then to write it in the new equation, the equation of the parallel line in slope-intercept form. So we've got y minus 4 equals distributive property, negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. I need to have my y isolated. It's going to be y equals mx plus b, so I'm going to add 4 to both sides. Y equals negative 2x. Negative 2 and 4 is positive 2. That is your new equation. Now, even though it doesn't tell you you need to graph, we're going to go ahead and graph this so that you can actually see the lines will be parallel. Okay, so we're going to go ahead and graph. I'm going to graph these in 2 different colors. So we're going to graph the first one, y equals negative 2x plus 5. It has a b of 5. It's going to be negatively sloping, so it's going to go down 2 and 1 to the right. Then I'm going to go up 2 and 1 to the left. And then I'm going to connect my points. You'll want to use a straight edge. I don't have that luxury. And that is y equals negative 2x plus 5. Now I'm going to graph y equals negative 2x plus 2. So 2 is the b. Here, the b value. I'll write b underneath there. The m value is going to be negative 2. And so we're going to go down 2 and 1 to the right. I'm going to go up 2 and 1 to the left. And then I'm going to connect my points. Again, you'll use a straight edge. I don't have that luxury on here. But then you can see that the lines are in fact parallel. This is y equals negative 2x plus 2. And so the concept that you need to take away is that parallel lines always have the same slope. And then in order to be able to graph that parallel line, it's really nice to use the point slope form. However, we're going to show you the other way you could have graphed it, and you make a determination as to how you want to go about doing this. Okay, so in this other way to graph parallel lines, you already know what m is. It's negative 2. All that you need to find then is b for the new equation. The b for the new equation will relate to this ordered pair negative 1, 4. So you just substitute into the y equals mx plus b formula. The y value is 4. Equals, the m value I already knew was negative 2, and the x value is negative 1. So you have 4 equaling 2 plus b. You subtract 2 from both sides to isolate b, and end up with 2 equaling b. So now you just write your equation. Once again, your equation is y equals negative 2x, that's your slope, plus 2, that's your b. This ordered pair negative 1, 4 will actually lay on this graph, this blue graph. So if we go negative 1, 4, negative 1, 4, you can see that the ordered pair negative 1, 4 is right on that graph. It has to be on the graph or you made a mistake. So that's a quick check to make sure that you got it right. It has to lie on the line. Okay, now on to that next problem. Okay, we're going to continue to use the point slope form as our first choice. And number 10 is write an equation of the line described. It passes through negative 6, negative 5, and it's parallel to y equals negative x plus 2. So go ahead and try this out. I would like you to graph it and then see that that point, negative 6, 5, negative 5 lies on the line. So I'm going to, okay, when you substitute, you get y minus a negative 5 equals the slope of the other equation of negative 1 times x minus a negative 6. Using the additive inverse, you get y plus 5 equals negative 1 times x plus 6. Use the distributive property. Negative 1 times x is negative 1x, or negative x. Negative 1 times 6 is negative 6. Subtract 5 from both sides to isolate y. So y equals negative 1x plus negative 11, or y equals negative x minus 11. Okay, you have a picture of a graph. You have y equals negative x minus 11. So I plotted the negative 11 here. It's just one below the bottom of the graph, gone up 1, 1 to the left, up 1, 1 to the left, until we eventually get up to negative 6, negative 5, which is the ordered pair we expected on that line. This is the original equation in red. Go ahead and write it. So y equals negative x plus 2, and the other equation was y equals negative x minus 11. Even though they're a long way away and my lines aren't very straight, you should still be able to see that they are parallel. In case you don't like that way, there is another way where you find b, because you already know m. So here's your other way. You know the slope is m equals negative 1. You need to find b. And so we plug it into the equation. Y equals mx plus b. So we know the y value is negative 5. Equals, we know m is negative 1. We know that the b value is negative 6. So plus b. Negative 1 and negative 6 is 6, so negative 5 equals 6 plus b. We subtract 6 from both sides. Negative 11 equals b, which means we have our x, y equals negative 1x, or negative x, plus our b minus 11, which is exactly what you had right here with the point slope form simplification. So you choose the method that works best for you, but this is a good use, this type of problem is a good use of point slope form. Okay, so we're writing equations of perpendicular lines now, and those are lines that meet at 90-degree angles. And the slopes of perpendicular lines are negative reciprocals. And what I don't want you to think is that they're always going to be negative. It means that it's going to have an opposite sign and that the slope will be a reciprocal. For negative 2, it will be 1/2. Sign is opposite, it is the reciprocal. For negative 1/4, the reciprocal is 4, the opposite sign is positive. For positive 3/4, the reciprocal is 4/3, but the opposite sign is negative, so it's negative 4/3. So let's go ahead and do this particular problem here. Okay, this is the same problem as before, except instead of being parallel, it's perpendicular to y equals negative x plus 2, but it is still going to pass through the ordered pair negative 6, negative 5. Your first step is to find the slope, which will be a negative reciprocal. Since negative 1, which is the slope, is negative, you change it to positive. 1 over 1, rise over run, is your slope. You flip it over, it's still 1 over 1 or 1, so m equals 1. Now we're going to plug it into the point slope form, which is y minus y sub 1 equals m times x minus x sub 1. We're going to go and plug into that. And we're going to use the new ordered pair, and we're going to use the new slope. So we have to use the new ordered pair and the new slope. So it's going to be y minus, and then y sub 1 is negative 6, or negative 5, excuse me, y minus negative 5, equals, the new m is 1, times x minus negative 6. We're going to use the additive inverse, y plus 5 equals 1 times x plus 6. You don't even need the 1 there, but we're going to leave it there so you can see that it is 1. Well, if you distribute this, 1 times x is 1x. 1 times 6 is 6. Then we have y plus 5 equaling 1x plus 6. Subtract 5 from both sides. Y equals x plus 1. Okay, we're going to graph that equation. So we've got 1. And then we're going to go up 1 and 1 to the right because this has positive slope. Up 1, 1 to the right. I'm going to go down a few now because I need to get close to that ordered pair, -6, -5. Should have done that actually first. Okay. There's your -6, -5. I should have probably just gone down towards that. Connect your points with a line. And it's -6, -5. You don't need to always go that far down, but it's nice to be able to see the intersection. Let's graph the other line. We've already done it once. I'm going to use a different color. The initial line is y equals -x plus 2, so plus 2 is here. And it's going to come down 1, 1 to the right, down 1, 1 to the right. I'll go back up 1, 1 to the left, back 1, 1 to the left. As you connect your points, you should see that the lines are intersecting at 90 degrees. So they are perpendicular lines. Okay, this is page 95, number 13. We're going to find the line that passes through -2, 3 and is perpendicular to the equation y equals 4x minus 1. First step is to find the slope, the negative reciprocal. The slope of y equals 4x minus 1 is m equals 4. The negative reciprocal is the opposite sign, a negative, and the reciprocal of 4 is 1/4. So we're going to plug it into the y minus y sub 1 equals m times x minus x sub 1, which is the point slope form. So we're going to have y minus, our y sub 1 is 3, equals -1/4, x minus, and the x sub 1 is -2. We're going to use the additive inverse just as an initial step. Y minus 3 equals -1/4 times x plus 2. Then we are going to use the distributive property. So we have y minus 3 equals -1/4 x. And then -1/4 times 2 is going to be -2/4. That will simplify. We'll do that in just a second. So y minus 3 equals -1/4 x minus 1/2. Now we're going to add 3 to both sides. And so we end up with y equaling -1/4 x. Now 3 is actually going to be how many halves? It's going to be 6 halves, and we take one of those halves away, so it's going to be -5 halves. Okay, so -5 halves. Now we've got y equals -1/4 x minus 5 halves is our equation. You have 6 halves minus 5 halves, which is plus 5 halves. Okay, so I graphed the y equals -1/4 x plus 5 halves. 5 halves is at 2.5. I go up 1, right to the middle there, go over 1, 2, 3, 4. There's 1 point. Then I go down 1, right in the middle, go over 1, 2, 3, 4. And it's not perfect, the graph, but you can see that the point -2, 3 lies on it. -2, 3 is right there, -2, 3. And then I'm going to graph the original equation, which was y equals 4x minus 1. So I have my -1 as my b. I go up 1, 2, 3, 4 over 1. Go down 1, 2, 3, 4 over 1. And you can see that these are intersecting at right angles. I know my lines aren't perfect. That's why it doesn't quite appear to be a right angle, but essentially they are intersecting at right angles if straight lines. Thank you. I hope this video has been of help on parallel and perpendicular lines.